This is TechCrunch.
Jet fuel is a modern wonder, allowing commercial airplanes to carry hundreds of passengers halfway around the world and military aircraft to regularly break the speed of sound. Yet jet fuel, as we know it, might be on the chopping block as the world strives to eliminate greenhouse gas emissions. Commercial aviation is responsible for 2.5% of all carbon pollution, a share that's likely to grow as other industries electrify, an option that's not tenable for long-haul flights. But if jet fuel can be made from carbon dioxide, it might get a stay of execution. A handful of startups have been racing to develop a cheap, efficient way to use electricity to transform CO2 into an energy-dense hydrocarbon that can be slipped into an aircraft's fuel tanks without anyone noticing the difference. But replacing inexpensive fossil fuels is a tall hurdle, one that many companies have failed to surmount. But one startup thinks it has cracked the problem with a fairly straightforward approach. We're not trying to necessarily reinvent the chemistry, Joe Rodden, co-founder and CEO of Lydian, told TechCrunch. We're trying to make the plant and the equipment far cheaper and also flexibly operated. The first half of that equation, cheaper equipment, has an obvious effect on the ultimate cost of Lydian's e-fuel. The second is more nuanced, taking advantage of a quirk of renewable power. Sometimes it gets really, really cheap. Lydian takes advantage of those low prices by using a very efficient catalyst to transform CO2 and hydrogen into jet fuel and oxygen. That allows the company to make the most of the grid's limited time offers. You can reduce your power cost by up to half by just shaving 20 or 30% off your utilization rate, Rodden said. To an experienced plant operator, running equipment part-time might not sound like the most profitable approach. Industrial facilities like Lydian's typically run 24/7 in an effort to wring the most product out of the costly equipment. The chemical process industry has been very good at optimizing those plants in the context of 24/7 operations, Rodden said. But when you break that assumption, you start to make some different conclusions, like maybe that component doesn't make sense. Can we get rid of it? Rodden said that because Lydian's reactors run part-time, his company has been able to eliminate a number of complex parts that add to materials and manufacturing costs. As a result, Lydian can produce e-fuel that's competitive with biofuels when electricity prices are around 3 to 4 cents per kilowatt hour, Rodden said, which is typical of some solar and wind farms. If power prices get cheaper than that, which they could by the end of the decade, he added, they might be able to compete with fossil fuels. Just how competitive depends on which market Lydian ends up selling into. Europe, for example, is capping the amount of pollution airlines generate, which promises to increase demand for biofuels and e-fuels, even if they're more expensive than traditional jet fuel. Elsewhere, smaller airports that have to pay handsomely for jet fuel deliveries may choose to install some Lydian reactors and make their own. But Lydian is also looking beyond commercial aviation. The U.S. military is the world's largest single user of fossil fuels, and jet fuel constitutes a significant portion of that. At bases within the U.S., securing supplies isn't much of an issue, but at forward bases in conflict zones, fuel has to be shipped in, creating an expensive and lengthy supply chain that's vulnerable to enemy attack. Some 3,000 U.S. troops in Iraq and Afghanistan were killed or wounded while delivering water and fuel between 2003 and 2007. That's an application where willingness to pay can be really almost unlimited, Rodden said. Instead of long supply chains, Rodden envisions Lydian reactors generating fuel as the base needs it, powered by on-base solar, wind, or nuclear power. The startup has received a DARPA award to further develop the technology. Recently, Lydian wrapped construction of a pilot plant in North Carolina that can produce up to 25 gallons of e-fuel per day. That might not sound like a lot when you consider that a Boeing 737-800 at cruising altitude burns that much every minute and a half. But Rodden said it's 100 times more than the company has been producing in the lab and 10,000 times more than when it started 2.5 years ago. Lydian will run the pilot for a few years, gathering data, while building a commercial-scale plant that it hopes to finish in 2027. If Lydian can maintain that sort of momentum, and the world can reduce its fossil fuel use, e-fuels might be the last hydrocarbon standing.